Okay, the next step is that we're going to set the upper half of the mold on top of the preloaded fiberglass gel-coated cavity side of the mold. So here's where we're actually closing the mold down in preparation for that injection process. So Don, if you would, help me lift this upper, and we'll set it down on top of the lower mold half. All right. You can see there that we've got the upper matching up. Now, we align the upper. We had, in this case, we've kind of two alignment illustrations. One were some Teflon blocks on the flange, but most commonly we use dowels on the outside of the mold. There are two dowel sets, a male and then a female receptor on the top, that set the X, Y, and Z plane of the mold half. So it puts the mold halves in registration, which is critical for part thickness, both thickness in the horizontal planes as in the vertical planes. So we need to give it registration. That also can be done with molding in or attaching to dowels on the surface of the flange. So we wanted to show both parts. All right, so what we're going to do next is just clamp it. Now these clamps certainly aren't to hold back injection pressure. They're simply to give a little help to getting that seal started. So we'll just clamp them down. All right, now the mold's ready. What we need to do next is hook up that flange vacuum. Remember that full vacuum area around the perimeter of the mold? We're going to connect the 3/8 or 10 millimeter line to it here. Now that'll be a yellow line. That simply plugs in. So this yellow line is full vacuum, 10 millimeter vacuum, drawing around this perimeter. So go ahead and turn the vacuum on. Now, if you notice that gauge, you can see that in the picture, we're pulling 23 inches. 23 inches is adequate, okay? I'd like to see 29, but 23 inches, and that's what we set it for in this illustration, is a point where we say that's an adequate amount of flange clamping vacuum. So that vacuum value that you see in that gauge represents what's happening around the perimeter of the mold. That's what's drawing the mold surfaces together and holding them in registration. So we're clamped now together. The next area of consideration is the cavity itself. We have a different vacuum going on there. There we're going to connect a regulated vacuum. Normally that vacuum level is going to be at around a half a bar, or about 15 inches of vacuum. So there you'll find that we've got a catch pot in place. So let's go ahead and put this assembly together. Okay, this blue line is set to a half a bar, or about 15 inches of vacuum. So what I've got is a lid where I'm going to bring that tube through. And then, if you remember, this was the vent. This is talking to the cavity itself. The fiber, dry fiber, is right below this, and this is where we're going to witness the resin when the mold is filled. Now, if we were to simply connect the blue line to here, and for some reason the operator was running in a manual mode, he wasn't running fully automatic, wasn't fire and forget, he was in charge of stopping the machine, and he fell asleep at the switch, as it were, well, then potential exists that he can continue to fill the mold, fill the line, and fill up the vacuum system. So in a bit of safety, we use a catch pot. In this case, it's 1 liter. Normally, we never bring a full liter of waste or into this pot. In fact, often we'll stop the resin as it's coming up, won't even enter the pot. And many of our clients, especially using the infuser PRG, one of their biggest pride factors when you come to their facility is they'll show you that they're holding their resin usage within, say, 10 grams or 5 grams or size of a quarter when into a catch pot, showing just how accurate they can repeat their process. But let's talk about that in a moment here. Let's show now, we're going to bring the halves, because this lid has a elastomer sealing on this flange. We're going to bring them together, and we'll start the vacuum. Now, that's obviously vacuum locked together. And again, this blue line is at a half a bar, So that means that this entire cavity area, remember that resin channel seal, the dynamic seal, is sealing off that high vacuum in this area, and the wing seal sealing off from atmosphere. So that's one vacuum environment. The second vacuum environment is in this cavity. Sounds confusing, but it's very, very simple. You simply have a full vacuum line and then a regulated vacuum line, and that's all the connections that are needed. We set the catch pot here. Next, all that we'll need to do in the next bit of this operation is the part you're waiting for, the injection. So stand by for that. Okay, the next step's the part you've been waiting for. We're going to inject, but you know, before we can inject the mold, we need a piece of equipment. Let me introduce to you the ultimate RTM injection system. Now, you say that, well, that's because it comes from JHM Technologies. No, I am sincere. It is the ultimate machine. It's a features set of history. That is, over the years, been involved in this ourselves together, nearly 70 years of experience. But myself, I've been in this since the late 70s, and I've had numerous opportunities throughout that time to think, boy, what if the machine would do this, or what if the machine would do that? All of those what ifs are involved in the PRG. It is a fully automatic machine, PLC controlled, close to the emulation of thermoplastic injection molding. That is, thermoplastic injection molding, we can control the profile of the injection, just as we can on a PRG for the light RTM process. We can control flow rates, pressures. We can step those rates and pressures and create a profile in a recipe when we're running automatic. This time today, we're going to inject manual. You know, before you begin injecting, though, you would want to be able to recirculate. So I pulled up the recirculation page. Here I can adjust the resin speed. So recirculation, why is that important? Well, if we were running filled resins, it's critical. But even with unfilled resin, having the ability to draw the resin from its reservoir, which in this case is a 5-gallon pail. Normally would be a 55-gallon drum, 500-gallon tote, or it could be a bulk system that we're connected to. But we want to draw the resin from its container, send it up to the mix head, and back to the reservoir. Now along that path, it's also going through, which you can't see, but in the back there is an inline heater. That heater will then set the temperature of the resin precisely to the temperature that we've prescribed it to. If we said we want to inject that resin at 30 degrees C, it would inject every time at 30 degrees C at the mix head. Not a heater in line from a paint system that fluctuates plus or minus 3, 4, 5, 6, 7 degrees we've measured. Our heater is PID controlled precisely with the PLC. And we set it up so as when the injection process is actually happening, that is, it's actually injecting into the mold, it's already checked and confirmed that it has pushed and recirculated out any resin that's in the hose that wasn't up to temperature. So when we say I want to inject at 30 C, it's injecting resin at that temperature into the mold. You don't get a cold shot of resin coming from the hose and then into the mold. So there's a bit more intelligence into it saying, well, I heat my resin in the line. Well, that's just one feature. And that heating can be done by set points of temperatures up to about 140 degrees F. We don't set the heater higher than that. And generally for polyester systems, styrene-based, methacrylate-based systems, we don't normally heat greater than about 35, 40 C is the high end. So you're keeping it around 90, 95 degrees, 100 degrees Fahrenheit. Those are the temperatures that we are normally injecting in. Injection temperature affects the flow of the resin through the mold. It affects the curing of the resin. So that is one of the critical factors that your process control revolves around. So that's just one thing. So while the pump is pumping, the heater is operating at the temperature that it's been told to stay at. When the pump stops, another feature is the heater isn't on. So you're never worried about setting a heater up. We've also have in line on this particular model, we have flow meter, mass flow meter, which tells us the exact amount of resin that's gone down the line and into the mold. Also will tell us specific gravity. If we're running filled systems, it will identify that we have the right filler load by the specific gravity parameters that we've put in for tolerance on high and low end. Here's again, operators over years, we have seen it countless times. Either didn't put the right amount of filler in or let all the filler settle to the bottom of the tank. So now he's pumping mud. And the symptom is there's having problems in the repeatability of the injection. Well, if we set parameters around the specific gravity, we know that the filler load is constant. We then say, well, we want the resin to go in at the same temperature constantly. We have that. Now we say, all right, I want to inject it, but I want to inject at a specific rate.